passes nearby. Now, ulnar and the radial nerve, etc., remember that there is this repetition that occurs in the name. If you've got a name that says radial, it may be involving or nearby muscle and the bone and the blood vessels and the nerve all having somewhat the same similar term, whether it's ulnar or radial, etc. Moving on. And you can see how these branches occur. Now think about this. If at the lateral or even earlier at the divisions of the anterior and posterior of the different trunks, etc., you begin to have cuts or damage due to any type of injury, self-induced or otherwise, you're going to have downstream a lot of loss of sensory perception as well as motor control. And this is critical because until those nerves repair themselves, the patient may basically have the situation where they'll lose sensation and feeling, but they may also start being subject to muscle atrophy. Okay? Now, moving down. We're going to go down to the lumbar plexus and then the sacral plexus. The lumbar plexus is, the ones I want you to know are the femoral, the lateral femoral cutaneous, and the saphenous. Okay? And you see these very clearly listed here in this diagram. And after that, you've got to go through the sacral, which includes, you can see this from the back here, the posterior view. Basically, the sacral will include the sciatic, the tibial nerve. Now watch how these pathways branch. Okay? And then you have the plantar branches as well as the common fibular. Okay? These are all important and major nerves, so I want you to get familiarized with them. These images you have in your text, take the time to use them. The other nerves, it is helpful to be familiarized with them, but those you need to know. Moving on. I mentioned to you earlier about Hilton's law. He said basically any nerve serving a muscle producing a movement at a joint also innervates the joint itself and the skin over the joint. This brings us to the concept of dermatomes. This is the area of skin innervated by a cutaneous branch of a single spinal nerve. Now, if you look at this, these maps, and they're taking the anatomical position, you can see where respectively the cervical, the thoracic, the sacral, the lumbar, and even, let's see, it's a little harder to see the CO1. But most of the nerves you can see. And this is kind of important also because of the fact is it's a way to tell where certain pathways are taking, and people are saying, I have tingling. Okay, is it in all of your fingers or only part of your hand? And if you notice, take a look at just the hand there for a second. Notice that the sensations around the thumb are at C6. In the index and in the middle finger is C7, and then yet at the ring finger and the small pinky finger, that's all C8. Now you might say, well, so what? Well, that tells you a lot. If somebody says my whole hand is inflamed, there's probably something that's not neural as much as it is perhaps something involving the entire hand, because you're having not one nerve but several nerves being activated. If you take a look up in the body region, in the thorax, for example, you've got the different, it almost like bands around the body. T1 through T2 through T3 to T4, going all the way down to T11 and T12. The reason I'm bringing this up is this would give you also perspective. Remember I said what happens if the hero on the TV program gets shot in the shoulder? Okay, he gets shot in the shoulder, and he can lose sensation in several of the areas, but not just in the shoulder, downstream, down in the arm, depending if the nerves are badly damaged. And how long will it take? Okay. The same thing is true with other parts of the body. Okay? All right. All spinal nerves except C1 participate in dermatomes. Keep this in mind. Some overlap of regions exists in the trunk area. Okay. Let's go back to motor endings, because remember we've been talking about nerves, and now we're talking about the motor side of things, not the sensory side. So if you go back to this, this is basically the image that you saw earlier of a axon terminal creating a synapse with a muscle fiber. You have the junctional folds of the sarcolemma. You've got the acetylcholine receptors, which also are ligand-gated ion channels. If you want, let's go back to the terminal button and remember a couple of other things. Synaptic cleft is about 50 nanometers. If you have an action potential, it travels down the length of the axon terminal. It activates voltage-gated calcium channels. They will open up. Calcium ions will flood in, and as they do, synaptic vessels containing acetylcholine will migrate down to the end of the terminal and fuse with that terminal membrane and exocytotically releasing basically the acetylcholine. Acetylcholine will travel across the very short distance, bind to those receptors. The receptors will open up, allowing in a flood of ions in and out that will cause a graded depolarization, which will eventually turn into an action potential traveling down the entire length of the sarcolemma until it goes down to T-tubules, etc. Okay, that was a quick review, and if you're not familiarized or it seems like it's difficult, go back to the chapter that was on the skeletal muscles. I believe it was chapter 9, and just briefly go over those particular areas, okay? When we got to smooth muscles, which is the latter part of, if I believe it right, chapter 9, what do you have there? Well, keep in mind that smooth muscles, cardiac muscles, and glands have these large swellings of the axon. Instead of axon terminals, they have sort of these varicosities, which really are just widening areas where you're going to find both the mitochondria to provide the ATP and the synaptic vesicles. They're going to kind of like dump it onto the larger area of the smooth muscle. So it's not going to be always a synaptic connection. It's almost like spraying out on top of the smooth muscle fibers. Now, the neurotransmitter will either be acetylcholine or norepinephrine. Now that we've gone through all of that, we've got to talk about motor integration. Now, what am I talking about here? There are different levels of certain types of motor behavior or motor function or motor action. Some of the stuff, think about it, you don't really even think. I ride a bicycle and my legs move in a certain position. I walk. Some you may have known individuals who did sewing, knitting, crochet. So what happens is they have certain stereotyped sequential motor actions. These are fixed action patterns. The sequence is all or none. Now, there's a motor hierarchy that runs through this, segmental, projection, and programs. One of the things you got to keep in mind is this. If you don't have to think a lot about it, you've developed the process where it's almost as if it's all handled at lower levels. What they call pre-command level, the highest, is one that really gets some feedback and gives sort of the orders to initiate. But then there are other systems that take over to make this almost an unconscious or almost an automated event. That seems kind of unusual because you're like, but I know I'm walking. Right. But do you have to think about it? No. Do you have to put one step in front of the other every day? Ding, 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 ding. No, you don't. You start walking, okay? because you've learned it, because it becomes more and more sort of a special stereotyped motor action. Let's take a look at these levels, and it'll probably make it a little bit more clear. Segmental level, spinal cord based. You have central pattern generators. These are basically circuits that control locomotor or other repeated motor activity. Segmental level is a select network, and this is in the anterior horn neurons, and it causes it to stimulate specific groups of muscle fibers. So in other words, if you're thinking about walking, think about this. You don't have to have other muscle sets aside of those that are involved purely in walking involved. You do have to have some feedback because you have to make sure that your walking is balanced and coordinated, etc. And that brings you up to the projection view. You're going to have some systems that are going to be involved. They're going to provide feedback because you need that internal feedback and also the coordination of it. So that's where you're going to have the motor cortex and the brain stem nuclei. And they're going to convey instructions to the spinal cord motor neurons and send a copy of the information to higher levels. So it's almost like saying, I am at a certain level. I tell the spinal cord to do something, but I'm also letting the brain know at the same time this is going on. Now you might say, well, isn't this minutia? Not really, because you have to think about this. Anywhere that you're going to have pathology, in other words, disease, damage, brainstem nuclei, etc., then you're going to have the improper orders sent down to the central pattern generators, and you're going to have improper information going back up to the parts of the brain that are involved with some of the more important command structures. By the way, keep in mind, if you notice there, the pre-command level includes the cerebellum and the basal nuclei. The cerebellum, I've mentioned to you before, is involved with coordination, balance, fine-tuning of things. Okay? When we get to the projection level, interestingly enough, it includes the motor cortex. That's the direct system. And it sends information via the corticospinal tract and regulates fine or fast movements. The brain stem is the indirect system. It's multi-neuronal systems, complex, regulates balanced or coarse movement or hand-eye coordination, which you remember I talked about punch drunk? Okay, that's where you've traumatized the brain in such a level that hand-eye coordination is very difficult. Now, let's get back to programs and instructional level. This is modified by feedback from the sensory input. What's the sensory input? Proprioceptors, sense of balance, etc. And these are going to provide information whether I can do this or not and help fine-tune and coordinate the output. Another way to think about it is this. Everybody likes to dance, but dancing the fine movements and understanding and practicing the steps, that takes a little bit of practice, and it takes some feedback knowing whether you're stepping there. You might have seen the old television programs where they actually would have footsteps on the floor to help people to know where to put their feet as they're doing fancy dances. Okay? I mean, the fancy dances that we see today on, Dancing with the Stars and all that other stuff, well, that was stuff that was very, very popular 50, 60 years ago. And places where people would meet, there would be whole ballrooms that would be, people would have to practice and really learn how to do the different types of dance and know where to put their steps. And that would take fine-tuning and coordinate output and, practice. Today, for example, you hear from such groups as SEAL Team 6 and Rangers and other types, and they'll talk about muscle memory. And just to give you some perspective, that's similar. Muscle memory is they've practiced and practiced and practiced so many times, breaking your gun down in the dark, putting it back together, swimming in the dark, putting all your gear together, and it's completely dark. So you know the muscle movements of how to do certain things in such a way that you don't even really have to almost think about it